section 8.6, we're talking about work problems. Well, we're trying to figure out how fast a job can get done, how fast the work can get done to complete a job. Well, let's talk about rate. We talked about rate before when we said that rate times time equals distance. Well, what if we think of that distance as just a job that needs to get done? Rate times time equals the job done. We can think about it that way too. We're going to use the same type of principles and we're going to solve problems of this sort. Okay, first one says Tom could mow his parents' lawn with a push mower in 4 hours. His dad could mow the lawn in 2 hours with a riding lawnmower. How long would it take for both of them to mow the lawn if they worked together? Well, let's take a look here. Let's find some rates first. Tom can mow his parents' lawn with a push mower in 4 hours. Well, we're dealing with hours, so we use that as our reference for time, our unit of time. So how much can he get done in 1 hour? That's what I want to know. Well, if he can mow a whole lawn in 4 hours, I suppose it stands to reason that he can mow 1/4 of a lawn in 1 hour. Well, all right. Well, how long is he going to be working? We found a rate. Now we need the time. How long is he going to be working? Well, we don't know that yet. Him and his dad are going to be working together. We don't know how long it's going to take them. We'll make that our variable. We'll call that t. All right, so this is how long Tom is going to be mowing. Well, we're also going to be figuring out what his dad's doing. Well, how fast does his dad do this? What's his dad's rate? Well, if he can mow a whole lawn in 2 hours, how much can he do in 1 hour? Well, he can do 1/2 of that job in 1 hour. He's also going to be mowing for that time because as long as they start at the same time, they're going to finish at the same time because the lawn will be done. They'll be finished. So there's his dad. That's how fast he can do it and how long he's going to be doing it. If we add these two together, we'll get the net result of their work. Well, what does that equal? Well, how many lawns are they mowing? Just one, right? That's going to give us one complete job. That's what we're trying to find out. Okay, so if this is Tom, and this is his dad, and this is a complete job, I'd say we've set up a pretty accurate equation here, something that's going to represent what we're trying to find. Well, let's take a look at solving this now. If I have 1/4 times t, I'm going to make that into t. Oh, that's a... Well, let's take a look at solving this now. If I have 1/4 over t, this is Tom's rate times his time, let's multiply that into one term. 1/4 times t over 1, we're going to make that t over 4. All right, we're going to add his dad's rate times time. That's going to be t over 2, same logic there, t over 1. And all that is still equal to 1 over here. All right, now we've got something that looks a lot like what we've been doing in the last couple of days. So we're going to find ourselves a least common denominator. We could use 4. Let's use 4. So we're going to multiply every term times 4. These 4s are going to cancel. That'll become a 2, and that's going to stay 4 over here. So we're going to get t plus 2t equals 4. All right, make myself a little more room here. 3t equals 4, and of course, if we divide both sides by 3, we'll get t equals 4/3. Now, what did we just find there? T equals 4/3. Okay, t stood for time, right? So 4/3 is the amount of time it's going to take. Well, 4/3 of what? Well, we said earlier that hours is going to be our unit of time, so it's going to be 4/3 hours. We can make that into 1 1/3 hours if we like, or since we're dealing in time, we could make that 1 hour and 20 minutes. So we just found how long it will take Tom, and his dad to mow that lawn. Bingo. All right, let's look at a similar problem. I'm going to skip this one for now. We'll go on to this one. We'll come back to that. If it takes Sarah 8 minutes to wash a car, it takes Beth 6 minutes to wash a car. How long does it take for them to wash a car if they work together? Well, remember, we're going to go rate times time equals work. or the job done. Okay, well, looks like we're dealing in minutes, so that's going to be our unit of time. How many cars can Sarah wash in 1 minute? Well, if she can wash one car in 8 minutes, I think it stands to reason that she can wash 1/8 of a car in 1 minute. Again, we've got our time. That's Sarah. Now we're going to add the work that Beth is going to do, and she can wash 1/6 of a car in a minute. She's going to work for T minutes. We're going to add those together, and all together they're going to wash one car. All right, well, so far so good. Sorry, this is Beth. All right, so let's take a look at how we're going to do the math here. Again, T over 1, T over 1. This becomes T over 8 plus T over 6. And that's going to equal... Now we're going to find the least common denominator. We'll say 12 doesn't work, 16 doesn't work. How about 24? All right. 24 works pretty well. We're going to multiply every term times that 24. Let's make a little more room here. All right. Well, let's do a little bit of canceling. We can cancel a 24 with an 8. We can reduce them both by 2 if we want. That'll give us 12 over 4. We can reduce again by 4. That'll give us 3t. All right. Well, let's cancel 24 with 6. Well, we'd have 12 over 2. We'd have 4 over 1. So we'll add a 4t. And all of that's going to equal 24. 4's looking a little janky there. 24. Okay, we'll add up over here. 7t equals 24. Divide both of these by 7. T equals 24 over 7. Now, 24 over 7 minutes, that's getting a little crazy. Let's make that into a decimal, shall we? 24 over 7. We're going to say about 3.43 minutes. 3 is about 3.43 minutes. Bingo. Okay. All right, now let's back up to that other page we skipped. Every year, the junior and senior classes at Hillcrest High School build a house for the community. It takes a senior class 24 days to complete a house and 18 days if they work with a junior class. How long would it take the junior class to complete a house if they worked alone? Okay, well, we're going to use the same type of thing. Equals the work done. Well, let's parse this out. Every year, the junior and senior classes at Hillcrest High build a house for the community. All right, that's cool, but doesn't contain any pertinent information. Except maybe that they're only building one house. They build a house. All right, so that's all fine and dandy. Introduction stuff, we can live without it. If it takes the senior class 24 days to complete a house, we'll stop right there. It takes the senior class 24 days to complete a house, a whole house, by themselves. Well, we can make a representation of the work they do here. These are the seniors. The seniors can do a whole house in 24 days. So if they can do 1/24 of a house in 1 day, that's great. We're going to multiply that times the time they're working. Okay, we don't know how long they're working yet. Now, in our next section, I'll use red, 18 days if they work with the junior class. Oh, okay. Well, we can figure that out too. Here we found how long it takes the seniors to build a house by themselves. Okay, that's all great and dandy. But what if they're working with the juniors? Well, we know they can do 1/24 of the work, and they're going to do it for 18 days. Now we know they're going to do 18 days. Okay, that's the seniors. Now we're going to add the work of the juniors. We don't know how long we don't know how fast they work. This is the juniors. We don't know how fast they work, but we do know they're going to be working for 18 days as well. What we don't know is how fast they work, their rate. We don't know how much of a house they can build in 1 day. We do know that after all is said and done, they're going to have one complete house built. Okay, make myself a little room here. Now, let's do like we did before. We've got the same type of equation. We just have a variable in the bottom for our juniors, but we can handle that. Well, let's parse this out. 18 over 24, that represents the work the seniors can do. I just condensed it, of course. Over here, we're going to talk about the juniors. We're going to have 18 over x, and all that's going to equal one completed house. Well, let's talk about a least common denominator here. It looks like 24x will do the job. Of course, we multiply every term times our least common denominator. We're going to cancel that with that. Our x here will cancel that x there, and nothing will cancel over here on the right side of the equality. So, 18x over here, plus, let's get our calculators out here. I can't do that in my head. 18 times 24, I get 432, equals, thank you calculator, 24x. All right, I like that. Let's take 18, we'll put it over on the other side. I think we'll get 6x equals 432. And calculator, I need you again because we're going to divide both sides by 6. And we're going to take 432 and divide you by 6. We're going to get 72. So what did we find out here? Well, what was our unit of measurement? We're talking about 18 days. So days is our unit of measure. Down here, we found that it's going to take them 72 days.